Hi, welcome back to my channel. Today's presentation is about statistical analysis and about the comparison of three groups or more in statistics. The presentation is a part of a playlist on observational research. I hope you watched previous videos. And I need to remind you that we are here describing a presentation as part of a playlist on observational research under the quantitative research methods. Now, the objective of today's presentation is to learn to perform a comparative analysis of the data and check the data variance of three or more groups of samples, and to learn about the variance as a basis of or for inferential statistical analysis. Earlier I was talking about the importance to distinguish and differentiate descriptive statistics and inferential statistics. We are here doing inferential statistics or parametric statistics, and inferential analysis is used to measure the reliability of conclusions about the sample of the population. Early on we were talking about different tests of inferential statistics. Today I'm going to talk about the comparison of three groups or more with unmatched data or with matched data. For the unmatched data I'm going to talk about the One-Way ANOVA, the Kruskal, Wallis and the Chi-square test. And for the matched data I'm going to talk about the repeated measure ANOVA, the Friedman and the Cochrane Q Test. Now, the structure of today's presentation will be mainly focused on the importance of variance, and then the three tests of unmatched data, and then the three tests of matched data before some takeaway messages. But allow me to start first with defining the importance of variance. Well, why do we do statistical analysis and what is the logic behind it? We conduct statistical analysis for six main purposes. Either to describe and characterize, number one. Number two is to detect variance. Number three is to compare and test hypotheses. Number four is to establish correlations. Number five is to predict and model. And number six is to prove causality. In today's presentation, I'm going to explain to you six different statistical tests that are mainly used in relation to Objective 2 and Objective 3. Now, why is the analysis of variance important? Because statistics starts with having some variation in the data. If the variance is zero, the system is deterministic and hence there will be no need for statistics. So, assuming this is not the case and that we will have a variance, by the central limit theorem, the mean of independent identically distributed random variables converge to a normal distribution, which in turn is unique up to mean and variance, giving prominence of this variance. Now, we need to understand what is the type of data that we are going to use in order to select the appropriate or the best fit test. And in this sense, we have two types of data, matched and unmatched. Matching aims to construct comparison groups that are similar according to a set of matching variables. This means that from the beginning, your questionnaire and your survey is designed to allow for this match of the data. But in most of the case, we use unmatched data. So here, the matched data actually helps to ensure that any observed differences in outcomes between the treatment and the comparison group can be more confidentially attributed to the treatment itself rather than other factors that might differ between the groups. But allow me start with explaining the first three unmatched data tests. The One-Way ANOVA test. Well, the One-Way ANOVA test or the analysis of variance test is a test that compares if the mean score of interval or scale type of a variable differs from the three or more groups measured as nominal variable. And in this case, we will have an independent variable with nominal value or more categorical values, and we will have a dependent variable with interval or scales that are represented as continuous data. And once we have that, we can start to check whether three or more means are the same. Now, there's some characteristic and conditions for the analysis of variance. We need to make sure that the dependent variable should be approximately normally distributed. The independence of the observation is a must, and we need to make sure that there is a homogeneity of the variance. Another important condition that we conduct the ANOVA test is that we use certain formula for that, and here is the famous F statistics that is used for the ANOVA test. The F statistical test is measuring the variance between groups and the variance within the groups. If we will have a null hypothesis, meaning that the variance between the groups and the variance within the groups equal to zero, then we will reject the hypothesis and then we will have a null hypothesis. But if the variance between the groups is significantly larger than the variance within the groups and we have a value of f higher than 1, then we can accept the alternative hypothesis. And I refer you here to watch the previous videos on statistical analysis for the comparison to a hypothetical value if you want to get more insight on that. Now, what is the second test that we conduct for unmatched data? The second test is the Kruskal-Wallis Test. Another famous test that relies on the following characteristics. The dependent variable should be continuous. The independent variable consists of two categorical groups. We need to make sure that there is an independence of observations. There is a dependent variable that should be approximately normally distributed, and there must be a homogeneity of the variance. Then we can move to the following test, which is the chi-square test. The chi-square test is simply a test used for hypothesis testing to determine whether there is a relationship between two categorical variables. In this example, for example, we are trying to compare the gender to the preferred newspaper, to the frequency of the television watching, and to the highest education level. And every time we can create pairs of variables like the relation between gender and the preferred newspaper, or the preferred newspaper and the frequency of television watching, and so on. And the chi-square is very helpful in this sense to compare in this sense. Some conditions for successful chi-square tests: the dependent variable should be continuous. The independent variable consists of two categorical groups. The independence of the observation is a must, and we must have dependent variables. The dependent variable should be approximately normally distributed with a homogeneity of the variance. Also, another important condition for the chi-square test is that the independent variable should be nominal, categorical, and the independent variable must be consisting of nominal groups, and there is independence of the observation like we mentioned earlier on. Now, this is the formula of the chi-square test. You can see that we use a formula whether for the observed frequencies that are significantly different from the expected frequencies, and here we can have observed frequencies of 0 and expected frequencies of E, where we have the chi-squared value equal to the sum of the observed value minus the expected value squared divided by the expected value. Also, as part of the characteristics for the chi-square test and the condition and the test assumptions is that when performing an inferential test, you begin from the point of the unknown, meaning that you will assume that there is no relationship between the variables, and in this case you will use the null hypothesis. And the alternative hypothesis means that a relationship between the variables exists. If you have a p-value higher than 0.05, then we are falling under the null hypothesis that there is no relationship between the investigated groups. And if we have a p-value under 0.05, this means that there is a relationship and there is an alternative hypothesis that is proved. Now let's move to another type of test, which is test number 4, which is part of the matched data. And here we can see that it's called the repeated measures ANOVA. Using this pre-test or using a pre-test or a post-test design with this repeated ANOVA allows us to have two groups and having a before the intervention and after the intervention test. So the repeated measure ANOVA compares means across one or more variables that are based on repeated observations. So we will have an observation, for example, in the summer and an observation in the winter. And then we can see the influence on the seasonality on the information. A repeated measures ANOVA model can also include 0 or more independent variables. Again, a repeated measure ANOVA has at least one dependent variable that has more than one observation. By that we can do post and pre-test and compare the sample or our observed subjects in relation to certain interventions. Now let's move to the following test, number 5, which is the Friedman test. And the Friedman test is a non-parametric test that measures whether there are statistically significant differences between 3 or more dependent samples. If it is used to detect differences in treatment, it is used actually to detect differences in treatment across multiple test attempts. And as you can see, the repeated measure ANOVA is trying to answer the following question: is there a difference in the mean or not? While in the Friedman test, we are trying to answer another type of question, which is there a difference in the rank? Based on that, we prefer and suggest using the Friedman test. This moves us to the last test of our analysis today, which is the Cochrane Q Test. The Cochrane Q Test provides a method for testing for differences between three or more matched sets of frequencies or proportions. The Cochrane Q Test requires that there only be a binary response like success, failure, 0, 1, and that there be more than two groups of the same sample size. So as you can see, the equation, it can be applied, it can be found in many statistical software. Now, I'm coming to the end of today's presentation. Some takeaway messages on the 6 tests we talked about today. Well, the comparison of 3 groups or more for hypothesis testing depend on how data is collected. And in general, there are 2 types of statistical tests that are used in hypothetical testing, matched and unmatched tests. Look at ANOVA and the Kruskal, Wallis, and the chi-square, the repeated measure ANOVA, the Friedman Test, and the Cochrane Q Test as statistical tests that are used to compare the means of the 3 or more groups, and they are often used in hypothesis testing to determine whether a process or a treatment has an effect on the population of interest or whether their groups or more have a difference from one another. Well, this is the end of today's presentation. I invite you to watch the following videos on observational research and statistical analysis. Today's presentation was about the statistical analysis for comparison of 3 groups of more in statistics. Thank you very much for your attention.